Moles and Solutions, Foundation Course 6.3. The chemistry laboratory is full of bottles of solutions. Not surprising when one considers that most reactions take place in solution. How do chemists know how much of a substance is in a solution, as this can vary a lot? Of course, they use them all. Solution concentrations. We can all tell when our tea or coffee has too much or too little sugar in it. This has to do with concentration. The more sugar you add to a drink, the more concentrated the solution becomes. Imagine you add a 5-gram teaspoonful of sugar to a 250 milliliter cup of tea. Its concentration can be described as 5 grams per 250 milliliter or 20 grams per 1000 milliliters, 20 grams per litre. It is usual to give concentration in litres. 20 grams per litre, however, gives us no information on the number of atoms or molecules, etc. in solution. Scientists therefore prefer to use moles per litre. Moles in solution, example 1. Calculate the concentration in mole per litre if 5 grams of sodium chloride are dissolved in 20 milliliters of water. We want our concentration in mole per litre, so need to convert the grams to moles and the milliliters to litres. Step 1. Convert to grams per litre. 5 grams in 20 milliliters is the same as 25 grams in 100 milliliters, which is the same as 250 grams in 1000 milliliters, which is 1 litre. Step 2. Convert grams of NaCl to moles. 1 mole of NaCl is equal to 23 grams for Na plus 35.5 grams for Cl, which is equal to 58.5 grams. You get all these values from the periodic table. 250 grams of NaCl is equal to 250 divided by 58.5, which is equal to 4.27 moles. So the concentration of 5 grams NaCl in 20 milliliters of water is equal to 4.27 moles per litre. Molarity. In chemistry, concentration should always be given in moles per litre. This is called molarity. Molarity means concentration in moles per litre. There are several ways to express the units of molarity. Moles per litre we've already used. Moles per cubic decimeter are also used and written mole / dm to the power of 3, or simply mole dm to the power of minus 3. dm to the power of minus 3 is equal to 1 over dm to the power of 3. Obviously, this shows that 1 litre is equal to 1 cubic decimeter. So 1000 milliliters is equal to 1000 cubic centimeters, and therefore 1 milliliter is equal to 1 cubic centimeter. Finally, molarity can also be shortened to just a capital M, as shown in the photo here. 1 m is equal to 1 mole per litre, often called a 1 molar solution. Moles in solution, example 2. Calculate the concentration in mole per litre if 22 grams of carbon dioxide, CO2 gas, are dissolved in 50 milliliters of water. Again, we need to convert the grams to moles and the milliliters to litres. Step 1. Convert to grams per litre. 22 grams in 50 milliliters is the same as 44 grams in 100 milliliters, which is the same as 440 grams in 1000 milliliters, which is 1 litre. Step 2. Convert grams of carbon dioxide to moles. 1 mole of carbon dioxide is equal to 12 for the carbon plus 2 times the 16 for the 2 oxygen atoms, which is equal to 44 grams. All values are obtained from the periodic table. 440 grams of carbon dioxide is equal to 440 divided by 44, which is equal to 10 moles. So the concentration, the molarity, of 22 grams of carbon dioxide in 50 milliliters of water is equal to 10 moles per litre, often just referred to 10 molar. Moles in solution. Practice question 1. Calculate the concentration in mole per litre if 12 grams of potassium bromide, KBr, are dissolved in 50 milliliters of water. You should now pause the video and try this question on your own on a blank piece of paper. You will need a copy of the periodic table of the elements. Please pause now. I hope you were able to get the same values as shown here. If you did not and do not understand why, then you should review the video or talk to me before continuing with the video. Moles in solution, example 3. Calculate the number of moles in 100 milliliters of a 2 molar solution of sugar. Now here we are told the concentration of the solution and need to work out the number of moles in 100 milliliters. To solve this type of question, we are just going to use simple proportion calculations. 2 molar solution tells us we have 2 moles in 1 litre. 2 molar solution is equal to 2 moles in 1,000 cubic centimeters. A 2 molar solution is equal to 0.002 moles in 1 cubic centimeter. I just divided by 1,000. 2 molar solution is equal to 0.2 moles in 100 cubic centimeters. Got that by multiplying by 100. So 100 milliliters of a 2 molar solution of sugar contains 0.2 moles. Moles in solution, example 4. Calculate the number of moles in 200 milliliters of a 0.25 molar solution of magnesium chloride. Again here we are told the concentration of the solution and need to work out the number of moles in 200 milliliters of the solution. 0.25 molar solution tells us we have 0.25 moles in 1 litre. 0.25 molar solution is equal to 0.25 moles in 1,000 cubic centimeters. 0.25 molar solution is equal to 0.00025 moles in 1 cubic centimeter divided by 1,000. 0.25 molar solution is equal to 0.05 moles in 200 cubic centimeters multiplied by 200. So 200 milliliters of a 0.25 molar solution of magnesium chloride contains 0.05 moles. Moles in solution, practice question 2. Calculate the number of moles in 125 milliliters of a 0.6 molar solution of lithium bromide. You should now pause the video and try this question on your own on a piece of blank paper. You will need a copy of the periodic table of the elements. Please pause now. I hope you were able to get the same results as shown here. If you did not, and do not understand why, then you should review the video or talk to me. If you got the practice questions correct, then you should continue to the multiple choice test, Moles in Solution, Foundation Course 6.3.